Hello, everyone in TPC. Today we are verifying identities. What that really means is that we are trying to prove equality between a claimed equation or for a claimed equation. So to do that, you're going to be given an equation and you're going to be asked to verify it. Basically, here are some of the rules and tricks and things to consider when verifying identities. First, you can only manipulate one side, and your goal is to get the other side to become identical with that side. So that's how you know you're done, is when both sides are identical and one of the sides you did not manipulate. In trig, we do this by substituting with other identities, but you can also do things like adding 0 because that doesn't change your expression, multiply by 1, factor, etc. Oftentimes, if you get stuck, one thing that is advised is to try turning everything into sine and cosine and see if things start to cancel. But the bottom line is you want to try something. Now, some things you cannot do, you cannot cross the equal sign. So these are not equations yet. So let me just start off with an example to show you what I mean. So here's our first example. Tangent x times cotangent x equals 1. So what I mean by you cannot cross the equal sign, properties of equality cannot be used until you have verified that this is truly equal. So you can't just add 5 to both sides. That's illegal. You have to verify that this is equal before you can use properties of equality. Now, one thing you might do is go to Desmos and verify, look for evidence that it's true. So, for example, I can type tangent of x times cotangent of x, and that should be equal to what the claim is. It doesn't like something that I typed. Let's try that. That should be equal to what the claim is, y equals 1. It does, in fact, look like it is for all cases. Now, we will verify it, though, because to verify an identity, you have to verify it for all real numbers. We could never do that with a graph because we could never see all real numbers. So we'll verify it using other identities. So here's an example of how you might do this. You would first start with one of the sides, say tangent x, cotangent x, and your goal is to get that equal to 1. So the way we do it, here's one way to do it, is to just draw this line, leave the equal sign out. That's what we're trying to show, is that they're equal. So we could use the quotient identities. So tangent x is sine x over cosine x, and cotangent x is cosine x over sine x. Now, this other side, you don't have to do anything with the right side because that side's not what we're manipulating. We are trying to manipulate this side to get that side. So at the end, if we did this right, we will have 1 equals 1. Now, you could already see this is a fairly simple, straightforward verification. We already are going to end up with 1. And so we are done. So we could say, yes, look, we got 1 equals 1. This equation has been verified. Okay, now that one was pretty simple. Just really 2 steps is all you had to do. Let's do another one that might be a little bit more advanced. So here's the next one. Now it looks like a lot, but it's going to clean up pretty quick. So we always just start by rewriting it. Now we could check this on Desmos as well to see, are these the same? So You try to type this correctly. Cotangent x times sine x plus cotangent x times secant x minus cosecant x. And then how does that compare to cosine x? Wow, they look like the same graph. So it appears like they are the same. Now this is just evidence, very strong, convincing evidence that they are the same. This does not prove it. To prove it, we have to go through a formal proof using identities. So I'm going to try to manipulate the left side. So we'll start with the original. And I'll just draw my line here. And I just have to keep going until I get cosine x. Okay, so I don't know, I might start by saying, well, I know that, I don't know, cotangent is cosine over sine. So maybe that's where we start. Okay, so now I see that my sines cancel, so I have cosine x, so that's pretty cool. So I have cosine x now, plus cotangent x secant x minus cosecant x. I don't know, that seemed to work out pretty well. Maybe we do that again here, right? Cotangent is cosine over sine. Now, I don't know if this is going to clean up nicely, but the bottom line is you want to try stuff. And this is where if you've tried stuff and you can't see how this can turn into cosine, you could come in to drop in hours, share with me what you've done so far, and I might be able to help you get there. This doesn't look like I can do anything here, so next thing I'll try is turning secant x into 1 over cosine x. Okay, well, now that actually looks like that's helpful. Now I can cancel my cosine x's. So now I can rewrite this as cosine x plus 1 over sine x minus cosecant x. And wow, check that out. 1 over sine x is cosecant x. So these will subtract to be 0. So I can't just cross them out yet. I have to show every step. So I have a choice here. I can either rewrite 1 over sine x as cosecant x, or I could rewrite cosecant x as 1 over sine x. It doesn't matter, but that step has to be done before I can cross them out and call them that subtraction 0. So I am going to call this cosecant x. And now when I combine my like terms, cosecant x minus cosecant x is 0. I now have cosine x, and I'm also left with cosine x on this side. This has now been verified. Here's what it looks like full screen. Feel free to pause this video, take a screenshot if you need to. There's the second example. You have 2 other examples you need to try on your own on Schoology, and then start your WebAssign.